Welcome to the TS Learning software. My students and I are thrilled to have you join us in this educational journey.
Hello, I am Parmis. This section is about linear equation. Part 4. Distance formula. Change in variable. When we want to represent the change of a variable like t, for instance when it changes from t1 to t2, we represent it as delta t, and its value is equal to t2 minus t1. Example. Find the change in x when the initial value of it is 5 and the secondary value of it is 15. Solution. The initial value is 5, so x1 equals 5. And the secondary value is 15, so x2 equals 15. Therefore change in variable of this value x is 10. We will show the value of x1 and x2 and delta x on the number line. x1, x2. To reach from an initial variable to a secondary variable, we need to add amount of the change of that variable to the initial value. Look at the changes in the coordinates of point 12, 3 as it moves to reach position 5 minus 3. It means to move 7 units to the left. It means to move 6 units down. But we need to know the green line shows the shortest distance between the 2 points given. This is called the undirected distance between the 2 points. The undirected distance between 2 points. First you need the coordinates of 2 points. A, x1, y1. B, x to y2. Then use the following formula. To derive formula, look carefully. Using the Pythagorean theorem, so we have example. Find the change in x and change in y when point A, 3, 4 moves towards point B, 10, 3. Solution. The initial point is 3, 4, so x1 is 3 and y1 is 4. The secondary point is 10, 3, so x2 is 10 and y2 is 3. Therefore, delta x is 7. And delta y is -1. Now we calculate the undirected distance between them. Solution. The undirected distance between A and B is 5 times the square root of 2. Example. Find the length of median AM of the triangle having vertices A and B and C. Solution. For better understanding, we draw an imaginary triangle. First we find the coordinates of the midpoint between points B and C. Now we use the distance formula for 2 points A and M. And we obtained the square root of 52. The distance between a given point and the given line. The distance between a given point P from the given line in standard form is given by this is the shortest distance between the point and the given line. Example: find the distance between the point P and the given line below. We first substitute the coordinate of the point on the left side of the equation of the line in the standard form. Now we substitute the coefficients of x and y from the given line in the denominator of the distance formula. And finally, we obtain the numerical result of the formula. Example: find the radius of a circle with its center at the point P and tangent to the line for y equals 3x plus 3. Solution: for enhanced understanding, we will draw a mental image. It's clear that the radius of the circle is the same as distance from the given point to the line. Therefore, we use the formula for the distance from a point to a line. But the equation of the line must be written in standard form. Substitute the coordinate of the point on the left side of the equation of the line in the standard form. Substitute the coefficients of x and y from the standard form of the line in the denominator of the distance formula. So the radius obtained 5. The distance between the two parallel lines in standard form. The distance d between these two parallel lines can be calculated using the formula. Note: when two lines are parallel in standard form, the coefficients of x and y must be the same. Example: is the line L1 parallel to the line L2? If the answer is positive, how far is the distance between them? Solution: to prove that two lines are parallel in standard form, we must first show that the coefficient of x and y are equal. For this purpose, we will try to equalize their x and y coefficient. First, we multiply both sides of equation L1 by -2. We saw the coefficient of x and y in both equations are equal, so two lines are parallel. Therefore, the value of a and b are equal to the equal coefficients of x and y in the equations of parallel lines. So the distance obtained 0.9. The distance between the two parallel lines in slope-intercept form. The distance d between these two parallel lines can be calculated using the formula. Note: when two lines are parallel in slope-intercept form, the coefficients of x must be the same. Example: a circle is tangent to two parallel lines. Find the circumference of the circle. Solution: It is clear that the distance between the two mentioned lines is the same as the diameter of the circle. To calculate the circumference of a circle given its diameter, we use the following formula. In summary, distance formula. 1. The distance between the 2 points. 2. The distance between a given point and the given line. 3. The distance between the 2 parallel lines. A. When the equations of 2 lines are in standard form. B. When the equations of 2 lines are in slope-intercept form. Your effort is appreciated.
Thanks for watching.